Hello, YouTube. The problem I'm going to be doing today is 12113 Team 9. So there's a problem on the later side of the Team Water middle school contest, and it's about the difficulty of the test that you'll start to see come out right about now. So what is this question asking? This question asking, what is the smallest value of A such that this inequality holds true for all real numbers x? So what we do, right? First thing that you'll need to know for this problem is you have a bunch of exponentials, right? Like, I don't know, something to the power of x. And we have lots of them. We have 3 of them. And we like to get rid of some of them, right? So the first thing we can do is that we can first divide everything by 4 to the x, right? Because that does 2 things. That gets rid of one of them, and that gets this a all nice and isolated. So we have a plus 9 to the x over 4 to the x is greater than or equal to 6 to the x over 4 to the x. Something else that you'll need to know to be able to simplify all of these, right, is that ab to the x is equal to a to the x, b to the x. So you can basically take apart whatever is under the exponential. So what this gives us a plus 3 to the x times 3 to the x over 2 to the x times 2 to the x is greater than or equal to 2 to the x times 3 to the x over 2 to the x times 2 to the x. And so you see that cancels and simplifies. And for now, for sake of simplicity, let's let n is equal to 3 over 2 to the x. Why? Because this is a 3 over 2 to the x. This is a 3 over 2 to the x. So what does it give us? This gives us a plus n squared is greater than or equal to n. Now this seems a lot simpler, right? Let's make it simpler by just moving the n to the other side. And so now we basically see if n is just any number we pick, right? This is just basically a quadratic now. So if this were a quadratic, we want this to be greater than or equal to 0. That just basically means that the tip of the quadratic has to be greater than or equal to 0. So we're going to talk about a technique that's just really powerful for quadratics. Usually if you see any quadratic and you want to know more about it, the first thing you do is plug in the quadratic formula to learn its roots, right? But that's just kind of like something you plug into. Here we're going to use completing the square, which is basically can get you the quadratic formula and potentially just more things. So let's go ahead and do it, right? So we have n squared minus n, right? If we want to complete the square, what do? We take the coefficient of the n term or of the x term, right? That's -1, right? We divide it by 2, and we take the square, right? What does this give us? It gives us 1/4, right? So now we're going to add 1/4 and subtract 1/4. And then after this, this is now a perfect square trinomial. It's n plus whatever this coefficient is, right? Plus -1/2 squared, and then we finally append our -1/4 that we left out. So let's substitute this in, right? We have n minus 1/2 squared minus 1/4 plus a. We want this to be greater than or equal to 0, right? So we can clearly see, right? Since we know that square of any number is at least 0, if we just let a equals 1/4, we're done, right? So a equals 1/4 works. But can we do any better? Can we get any smaller a that works? Well, that's not, we can't really, right? Because n is equal to 3/2 to the x. That's kind of like if you just draw a graph, right? 3/2 to the x, like something, every exponential graph looks like this. And it's always going to be equal to 1/2 at some point, no matter what you take to the power of x. For some x is always going to be equal to 1/2. So we know this will be equal to 0 at some n, right? At some x. And so if this is equal to 0, then we need this to be at least 0 as well. So we kind of have to pick something greater than or equal to 1/4, right? So we know that a has to be greater than or equal to 1/4. We know a equals 1/4 works. So we know that this is the minimum possible a. And so basically, as a recap, what do we do to solve this problem? To solve this problem, we need to know 2 things. We need to know that we need to know our exponent rules, ab to the x is equal to a to the x, b to the x. And second, we need to know how to complete the square. We need to know if we have any quadratic, right, that we don't just mindlessly plug into the quadratic formula, right? It's much easier. It's much more intuitive, gives you more insight to just know that completing the square gives you more information. And so by using these 2 techniques, we were able to basically turn this weird expression all the way back into something that was easily manageable.
Hi, everybody. This is Tim. Hope you're enjoying our videos. If so, you know what to do. Like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.